Hi everyone, my name is Doug Kras, and I'm going to teach you about the adventures of IoT hacking. So who am I? I am a hacker. I am a security testing consultant at Aon Cyber Solutions. So at Aon, we offer a wide variety of different tests, including penetration testing, DFIR testing, high-value asset testing when you get into more of the red teaming, physical security testing, a lot of different tests. So if your company is looking for security testing, we can provide that. I'm also a continuous learner, and my wife would say I'm a mega goober. So what is IoT? Well, it stands for Internet of Things, and we're going to generalize it a little bit for this talk. So we're going to say that it's some kind of product. It has some kind of connectivity. It could be Bluetooth, could be online, could have HTTP servers or something. And they read data, do some kind of function, right? It might be like a temperature sensor that reads your temperature of your fridge and says, hey, you left the fridge open. It's rising, maybe you should go close your fridge. So what do we have, right? We have the temperature sensors like we talked about, security cameras, but now we're putting everything online, right? We want to put our washers and our dryers and our fridges. Yes, all new, exciting, smart home stuff. Did it get tested? I don't know, maybe not. So we classify it, things that are online, really not your normal computer. And they don't always get the best testing. Maybe the company just doesn't have the ability to test. They don't have internal test teams, and they don't want to pay $75,000 a product every version to push it out. So it just goes in prod, and we'll see what happens. So why do we want to hack these devices? Well, we said they're less secure, so sometimes you can find some cool things. They're a lot of fun. There's a lot of interesting vulnerabilities that you find. Like I found a vulnerability where when you sent input into this field, it caused a denial of service. The IoT device totally stopped functioning, and then it just vomited source code onto your web browser. Hey, source code disclosure, that was easy. There's a lot of different attack surfaces too, right? We don't have the standard, like you have the standard network style areas, but you also can get into hardware. So you can get into removing the chips or connecting to hardware debug interfaces. And it's really hard to hire IoT pen testers. I was looking for someone to join my previous team. We couldn't find anyone. It took a really long time. So it'd make you really marketable. Hey, it's another thing that I have in my toolkit, so I can do networks and web apps, and I can do hardware. Companies are going to want to hire you. So what kind of skills do you need for starting? General electronic knowledge, but not like super crazy, right? Can you look at a PCB board and start Googling components? Might be all you need. Maybe identifying some chips and it says, hey, this is a flash chip. Okay, so what does a flash chip do? And Google will tell you, maybe it stores your firmware, it does this function and that function. You don't have to be a crazy coder either, right? C code is very easy to understand, and you can Google the C code and say, hey, what does this function do? And Google will gladly tell you, well, it takes an integer and a pointer, and it does this with this, and here's the results. And you can infer what the IoT device is doing based off knowing what that C function does. And then soldering, sometimes you got to solder directly to the board or directly to processor pins, which is really risky and something I don't recommend, but there's test points typically on boards. So if I want to connect to this specific test point, well, it's over here on the board and it's this pin on the processor. These connect, I can solder there, and we can connect. And in a sense of adventure, there's not a lot of good documentation out on kind of how to go about and do IoT pen testing. So you have to get creative and just don't be afraid to try things. Sometimes you might try things and brick a device. Done that, lots of fun. Oops. But it's a really fun field. So let's get into some hardware attack surfaces and then some network services. So we have UART. This is Universal Asynchronous Transmit and Receive. And you can normally connect to this and then it will connect to the processor. Sometimes you can interact with the bootloader, and the bootloader will tell the device, hey, this is how you need to boot up. So you need to run these commands, then talk to Flash, get the firmware, and then do some other things. You can interrupt this process, and you can sometimes get shells, sometimes dump firmware. Use the JTAG protocol as well. This one's more interacting with some of the memory. So the device, might boot up, it might run some kind of binary. Let's say your firmware is encrypted. But if you can dump the memory off the processor, maybe there's an encryption key in there. So now you can use that encryption key to decode the firmware, decrypt the firmware. And now you can start doing more analysis and start finding bugs. I know there's the SPI protocol. This will send data, typically like 1 bit at a time across a bus. And you can connect via SPI and you can read that and kind of see how the device boots up or other things. And IoT devices have network services, like you're doing a standard web app pen test. So you might have HTTP servers, HTTPS servers. They always use self-signed certificates because nobody ever interacts these with actual certificate authorities. You have things like MQTT and MQTTS. This is like a published service. So you might send your data from a temperature reading, hey, it is 95 degrees, and you'll publish that to your topic on that server, and then the MQTT server might do something based on that, right? Alert that your fridge is open. And then there's upgrade mechanisms. Maybe you're doing it over USB or over like a HTTP server, and then there's Bluetooth as well. So maybe you can mess with the function of the Bluetooth when it's connecting to a device or doing firmware upgrades or something like that. So let's get into disassembling devices. Here's a picture of a router, and you can see you want to like carefully open these because you can easily snap pins and other things. You don't know what's connected underneath, so you might rip ribbon cables or something. And then you can see, it's kind of hard to see because it's small. That's not what I want to do. But you can see some of these chips here. It's like the one on the bottom left. It's really hard to see. It says WinBond and there's a chip number. So you could Google that and say, what does that do? And what your results will tell you is that's the RAM for this device. So on the chip that's upside down, it says Broadcom. So you Google that, you find out it's a processor. This one's not as nice because the chips aren't on the outside, so it's harder to pin out. And then the small one with the 8 pins to the right of that is the flash, and that's where your firmware is going to be. So if you need to dump firmware, you might be able to interact with that and dump your firmware. And then you use the firmware to understand how the device does all its different functionality and then look for vulnerabilities. So what do we need to communicate with these IoT devices? Well, you need things like a multimeter. So this can help you measure voltages on the device. It can also help you pin out different pins. So if you're looking for a specific pin, you might hold this end on the pin and this one on a test pad or vice versa, right? You might put this on a test pad and say, where does it go? And then brush this across the processor. And as you hit the chip that it electrically connects with, it'll beep. So if you flush it real quick, you go, oh, it beeped on the bottom row. So now I can go 1, 2, 3. Okay, this is chip 65. And then I can look at the processor diagram to know that chip 65 does XYZ function. Then we have things like a USB to serial analyzer, or serial cable. This just lets you connect to things like UART. It's just an interface. You can pull it up in PuTTY and have like a nice little shell. Watch the device boot and stuff like that. Then you have a logic analyzer. This helps you kind of look at the voltage up and down. And good logic analyzer software will also help you say, okay, here's the actual characters moving across the line. And you can maybe find passwords or things like that. And PuTTY, if you're using Windows, just to connect to that USB to serial TTY. If you're on Linux, you can use things like Screen to connect to the USB drive or USB cord. So how do we go about attacking hardware? Well, we connect over that UART port. So that transmit and receive pin and the ground pin are normally you need ground. And you can watch it boot up, and we'll do this here in a little bit. And it'll come up and it'll say, okay, like we're gonna load the data section, and it's at memory address this. And now we're gonna load this menu, and it's at this address. So that helps you kind of understand what the addresses are. And then it might tell you things like, hey, I'm starting up Bluetooth, I'm starting up this, hey, my IP address is this script might have failed, or I'm running, /var/www/boot or something. So you get some information based on that. So then what we can do is we can do what's known as interrupting the boot. So we're gonna power on the device. The processor is gonna go, hey, flash, I need the firmware. Sometimes you can just hold Control-C and the device goes, oh, interrupt, cool, we're good. And then you can start modifying arguments. Or sometimes you might have to short the flash. So the processor goes to read the flash, but the flash is not there. It can't read it. It's also a pin that's called the CS pin or the chip select pin. So if that's an active high or low, depending on what it is, you might have to short that pin. So when the processor tries to read it, doesn't know what to do. Lots of devices just fall back into a root shell and say, here you go, you win. Sometimes you have to actually modify some boot arguments and go from there. Get the shell, pwn the device, dump the firmware, find more vulnerabilities, and have all the fun. So let's look at what doing a UART connection would look like. So it might look something like this, right? At the top red box, we see it's disclosing the CFE. It's a bootloader, and then there's a version. You'll be shocked to find out the amount of versions that are like, oh, we're running 2008 because we've never updated our hardware, because why? And then at the bottom, you can see some of the memory addresses, like the data partition, BSS, some of the stack. That might have good information if you can dump that. And then, like we talked about, you might have to short that flash chip down there. When you're looking for UART, there's 4 pins down there at the bottom, and 4 pins normally tells you that it's UART if they're in a row. But still pin them out, because if you were to plug the wrong pins in, you might plug into the VCC, which is the actual voltage port. And if that is plugged into your computer, it may fire power back into your computer. You might fry your motherboard your second week of work and have to tell your company you need a new laptop. Yay. Oops. So what kind of software do we need? Well, on Linux, you can use things like Screen, NM, and Binwalk. I think Binwalk's also on Windows. NM will let you identify different functions that are in binaries. So you can look for things like command injection, where you're doing like system calls or exec calls, and that'll help you go, okay, I want to look at this binary, right? Because we can't look at 254 binaries on a device with hundreds of thousands of lines of code, and reversing that would take forever. Binwalk you can use to extract firmware images. You might have like a .bin file or a zip file. And what it does is it looks for magic bytes in the header of the files and then identifies, hey, it's a zip file, I know how to deal with this, and it'll extract it out for you. You can do it recursively. So then you go from a firmware image, 6 layers deep, you finally find like a Linux standard operating system file format. On Windows, PuTTY, Ghidra for reverse engineering. There's also things like Binary Ninja and IDA. They're expensive. Ghidra's free. Very nice to have a free decompiler that you can use that, in my opinion, is good enough to go find bugs. When I was doing this at the enterprise level, they had IDA, and I just learned Ghidra better, so I used Ghidra, and same effect, found all the bugs. You can also use Windows Subsystem for Linux. Sometimes it can be good for like just running quick NM to dump the functions, but I wouldn't use it for anything like interacting with the device over a hardware protocol. I would just do it in a virtual machine. When it comes to virtual machines, right, you might want to do exploit development or testing. You might want to emulate the firmware, so you could just take that whole firmware image, emulate it in a virtual machine, and then do your testing, and also build out like fuzzing inside your VM. That way, if you do something that breaks the VM or you make a bad change, just roll back or start a new VM and it'll be all good. So how do we get into practicing reverse engineering? Because this is not something that's super easy to do. You can just download firmware. So what I like to do is I look at write-ups from places like Cisco Talos or Pentest Partners in this case. And people like to write blog posts. Aon also writes blog posts about vulnerabilities they found. And then here's how we found it. Here's what the vulnerable code looks like. And then once you understand what to look for, you can use that same methodology across all your tests. You can get very quick at going, okay, these binaries have system calls. They're probably interesting. Let's look at them. This one seems to do nothing. There's no exciting system calls, so let's ignore it. So that's a really great article read. Highly recommend it. I think my slides will go up probably on Circle City or on Aon's website as well. So we get the firmware. We went to vendor.com and we downloaded it. Can use binwalk to extract it using all those magic bytes that it can find. And this is what you'll probably end up getting, assuming you have some kind of Linux OS. A lot of IoT devices use embedded Linux. Same exact concept as Linux, just a smaller format. So you see we have things like dev, etc, home, all the folders that you would be used to if you have run any kind of Linux. When you extract these folders, it will have an underscore in the folder name. So that way, you know, like, okay, that's the extracted one. It's successfully extracted cd underscore tab, and then just go down the line until you find this. So this is what it would look like when you've actually done it. You can see that it thinks there's a bunch of zips in here, and then eventually it'll just extract it out. EM is the option. E is for extract, M is for something, but it basically recursively does it. If you just ran tac E on the firmware, in this case it's a zip file, it'll only do it one layer deep. Then you have to cd, and then you have to do the same thing again. So just run tac M, EM, and it'll go all the way through the firmware. So we go through, we find something like this, like we saw in the previous slide, and we have Linux systems, we start looking at some of the different directories. So how do we go about finding some of these vulnerabilities? Well, you want to try and start fuzzing some services. So I would look for anything that you think is going to be listening on the network, and then you could just send it random data, whether it's a post field or it's, you know, a random binary listening on a port. Like, what happens when you send 500,000 A's? Does it just crash? Cool. At what point does it crash? Can you change that crash into something you control to get code execution? And then you can also do reverse engineering, which is my favorite part. Go look at what those binaries are on the network services, start going through some of their functions, Google for, or search for different keywords like system and exec and things like that. SF, print, those will possibly help you find command injection as well. And then you can look to see how the function is going to handle the endpoint. So maybe you make a post request with the username, so it takes in your username, and then below it checks, you know, is your username in var www.users.txt or something to know if you're a valid user. And once you know how those inputs are handled, you can learn how to manipulate them so that you can find issues. So what kind of vulnerabilities do we typically find? Remote code execution, all the time. It's trivial sometimes at how easy it is to find some of these. Buffer overflows, a lot too. A lot of IoT devices don't implement the controls like address randomization. So a lot of times it's easy to find buffer overflows. You can do malicious firmware updates. What happens if I put a backdoor in that zip file and then I update it? Are we doing signature checking on our IoT devices to make sure that it's actually a valid firmware? A lot of times not. There's the debug interfaces, UART, JTAG are the big ones. Just connect to those and you might easily be able to get access to the device. IoT, or denial of service in IoT devices, when you send bad strings or a lot of packets. And then a lot of like unencrypted communications. I've seen devices update over HTTP, so a well-positioned attacker on the network, or if it's your own home lab, you could just Wireshark that and pull the firmware right out. Because maybe you can't just easily go to the website and download it. Or you could find the binary that's responsible for that, and you could find the password to their website that lets you just log into their website and download all the firmware. So let's look at finding command injection. This is a pretty simplified example. So we have our function here. The important thing is to know there's a character pointer to an argc and an argv, and you have this command, right? We're setting this command variable to user bin cat. So I'm going to make a binary that literally just cats out a file. And then if you look at stircat, it's got two arguments there, right? Command and argv1. And argv1 is going to be what's user controlled. So argv0 would be the name of the program that you're running, kind of like when you do Python stuff. And then 1 is going to be the argument you supply. So we control argv1. So Google, what does stircat-c code do? And it'll show you this, and it'll say, hey, it takes a character pointer to a destination, and it should contain a C code. In this case, it was that user bin cat command. Source is the string that's going to get appended. So now we have user bin cat, whatever I want it to be, and then it's going to return a pointer to that new string. So now, when the program runs, it's going to run system on that new string. So we'll have command and argv1 just get combined with the space, basically. So since we're going to cat out this command, let's find command injection. We can just simply, in this case, put in a semicolon, because Linux, if you want to run like cd and ls, you do cd semicolon ls. Same concept here. Give it a file, and then you give it a bad file too, and if you didn't want to actually cat out the file, and then just start bin netcat, now you have a listener, and you could connect. So maybe I can only interact with the website, but I find this kind of command injection, but I can open up a port back so that I can reach out and connect to the device and do further attacks. So now we can connect remotely to this. So let's look at some more. This is a little more complex, right? But what we see is we have this SSID that is a post parameter. So this is probably you're setting up your device. You moved, you need to change the Wi-Fi or something. So it runs this really long command, user bin, blah, blah, blah. And then you see at the very end that %s is going to be where the SSID variable gets injected to. And at the bottom, we're going to exec systems. We're going to call system on this whole command. So it's like we're sitting at a Linux terminal running this really long command. So if we Google what does snprintf do, it looks like this. Stir is going to be where the string is going to be stored. Size T was the maximum number of bytes. And then the last one is the format of the C string. So in this case, it's like 100 bytes long, which is plenty. So we can inject into that %s field that we saw before. So you can just break out of the command, add your semicolon, run the command, and then always remember to use the pound symbol after that because it'll comment out the rest of the code. So maybe your code injection happens here, but the command is this long. So like all this stuff will still be part of your command. But if you have that hashtag in there, it'll comment the rest of that out, so it just runs your own command. So we look at what our exploit would look like. It's a post request. Nothing, the bottom is super important except that SSID. That's that variable that we're going to set. So we're going to put a double quote to escape out and then a single quote in our semicolon. Now we're totally escaped out of the command. In this case, just ran who am I, and then the command becomes that really long thing, but we're interested in who am I. Any command here works, right? You could wget to your C2 server and download malicious files or ransomware, or if you're doing security testing, download your own shell or something to get access to the device. So what else could we do with this? Well, any command in Linux, right? You could put your own hash into Etsy Shadow and then put something else into Etsy password and log in. Sometimes IoT devices do weird things where they don't have separate Etsy password, Etsy Shadow, so you might want to look at the firmware ahead of time if you found command injections so that you know, like, okay, I just need to put this in Etsy password with a username and a hash and I can log in. You'd also modify like boot scripts or something like that so that you could just turn on SSH. Maybe SSH doesn't start normally. Ton of stuff you can do. So how can you get started? Well, you buy some kind of old router, a multimeter. You don't need those $500 multimeters, right? I'm pretty sure mine was like $10 and it works great. Soldering irons, get like a nicer one. I had a really cheap one and the tip literally melted off in the middle of soldering. Fantastic. But not super expensive. I think mine was like $70. Also a note, when you're soldering, be sure to get a fan as well because you don't want to always intake all that solder fume because it's not good for your body. So the fan will pull it away, it'll put it through a filter, so be sure to do that. Then go download some firmware off the internet, run binwalk, extract out the firmware, look for interesting binaries and go throw them in Ghidra. You don't have to be this reverse engineer expert, just start looking to see what do you think's going on. That's the entire purpose of reverse engineering. It's guess and check. So like, okay, I think that if I do this, then this will happen, and then it doesn't. Like, okay, well, why didn't that happen? Maybe your command injection's wrong. Maybe something else is wrong. Maybe you tried to run netcat, but netcat's not on the device because usually it's not. Sometimes it is. So you just got to play around and understand what kind of devices you might, or what kind of commands you might be able to run based on that. So how do we secure IoT devices? Because we don't want to just stand up here and say, hey, all these IoT devices are so insecure and awful and this and that. So you encrypt your firmware. As a company, put your firmware online for download, but it's encrypted. So now I need to know a password to get in. I need to decrypt it with your special key. That key might live on the device itself. So like issues there where if somebody leaks that key, then you might have to redo your whole encryption, but definitely worth it. Don't make plain text available. Teach your developers how to write secure code. Teach them what bad code looks like and why it's bad code, not just, hey, never use this, it's horrible. No, why is it horrible? Because I can do X, Y, and Z. Oh, okay, I didn't even know you could do that kind of stuff. So now I'll write better code. You can segment these devices. So corporate network, VLAN them off. Don't have them talking to your domain controller unless they really have to. And if they do, set up your own domain controller for just that and not the one that contains all your company secrets and fun stuff. You can disable the hardware interfaces. So you can do that in software and hardware. You could also, like, when you go to put out your production board, just don't put the traces in there. So now I have to connect directly to the chip. I'm not that great of a solderer. I don't have that good of a setup. So I'm going to ruin the chip, and you're safe. Somebody really wants to get in, like they can, but let's make it harder that it's not easy for someone, or they have to make significant investments in their tool set. Hack them before production, so let's get these things tested. Don't just, hey, we put it out, it works, great. Here you go. No, get them security tested by third-party firms, by your own internal team, just do it. And you can do firmware signatures, so I can't just push malicious firmware updates without having to mess with signature verification, and that, it's another level that makes it more difficult. All right, we're gonna try and do a live demo here real quick. All right, so I'm gonna open up PuTTY. I'm also going to check, so when you plug in a USB to serial adapter, it will enumerate, typically on Windows, as some kind of COM port, so you go in here, and we see that mine is on COM4. We'll take serial, we'll say COM4 baud rate is the rate that the device communicates speed-wise. So if you get this wrong, you may not be able to type things. It might look super gibberishy, but you can play around, right? There's scripts that'll auto brute force this, but there's only 6 that are typically in use. Normally it's 115,200, and that normally works. In this case, it's 56,700. So we'll connect to that. And this is what you should expect to see. You don't have to boot the device. This is just connecting to your interface. So we'll turn on the device, and you can see it's booting up. I don't know if you caught there, but it says, auto boot in 3 seconds, try and interrupt it. So if you turn it on and try to interrupt it, hit Control-C, nothing works. So turn it off. If you did more reverse engineering on this, you'll learn that the password is alpha168. So as it boots, you type alpha168, maybe. Now you can see, I can't seem to zoom in, but we're in the U-boot interface. So now we can do things like print environment variables out. And I'm sorry, I know this is really hard to see, but this is the long boot command that it's going to run. So you can just modify this so that it still boots the entire firmware. It'll go to flash and grab it. And then we'll just say, hey, you're in it, your first process that you need to do afterwards, let's just call it bin shell. So you change the arguments by using set-env. So we'll do that. You can also call the variables with $ curly braces, which will make your life much easier. Then you can run add-on at the end, bin shell. And then we're going to run the boot command. And now we see the device is booting up. There's all sorts of really valuable information. So if you log PuTTY, you can go back and read all this. And now it's going to go ahead and boot up. It'll start, in this case, there's a USB interface. There's a web service that's also running. So it'll do that. And after it boots, which takes a minute, you will end up with root shell on the device. And while that's going, I'll give closing thoughts and then we'll go back to the demo. So in closing, there's a wide variety of devices you can hack, right? There's thermostats, there's routers, there's IP cameras, there's all sorts of fun things. So it's a really cool field. It's got a lot of exciting vulnerabilities, and companies are struggling to hire these people. So you're definitely making yourself more marketable by being able to pen test IoT devices. And anyone that interviews with me and comes in and says, oh, I want to know what you're doing in your home lab. So if you're telling me that, yeah, I heard TP-Link or ASUS or whoever had some kind of vulnerability, and I went and I downloaded the firmware and I found replicated the steps. Oh, that's awesome. You're playing around in your home lab. I'll take somebody that's curious and playing around in their home lab than someone that's a super seasoned veteran, but they're not staying up to date on anything. Because I can help teach you. I can't help drive you. So it's a lot of fun. If we go back to our PuTTY session, this one actually didn't work for whatever reason, but normally you would just see the pound symbol and you would have a root shell there. And that's all I got. Thank you. It looks like we've got about 5 minutes. I'll take questions and we have 10 minutes. Cool. So thank you, Sled. If anyone is interested in being part of Aon, you can reach out to this email address. There is a link to our Aon Cyber Labs where we publish blog posts about cool vulnerabilities that we find. on engagements and things like that. And yeah, any questions? Yep. Yeah, absolutely. Yeah. Up front, he said the best place to go look for your thrift store. Yep, people will throw away all sorts of stuff and don't know what they have. Or eBay, there's a lot of like cheap stuff on eBay you can find for a couple bucks. Or ask your buddy, "Oh, I just upgraded my system. Cool, can I have that? I just want to tinker." Yep. Um, typically, yeah. So like, the question was, if you go to Best Buy or something, you buy something off the shelf. How easy is it really to find some of this stuff? Uh, Sadly, it's really easy. A lot of companies still miss these, even when they have bug bounty programs. Their team missed it, or bug bounty platforms missed it. Right? It's like any kind of website, right? We keep finding vulnerabilities in web services and things like that. That, oh yeah, this has been around for 20 years, but nobody thought to look. There's not a lot of people that look into IoT, right? So absolutely. Yeah, yeah. Yeah, so the question was, is this still a problem in all IoT? And I think the issue is that we just haven't been doing security that long around IoT, and people weren't, we're putting a camera on our network. Like, how bad could it really be? And now we're seeing that. Well, I'm going to use that as a pivot point. So your camera's public. I'll hit that, and then I'll pivot into your network as the attacker. So now I think companies are starting to go, well, maybe we should have thought about this because, imagine I bought device XYZ, put it on my corporate network, and now I'm calling that company going, what the heck happened? Why did this happen? Did you do your security testing? And sometimes the answer is no, and we need to do more about that. So if your company is a producer of some kind of smart thing, Bluetooth, Wi-Fi, network, SIM card, whatever, get your devices tested, because they're going to end up in your grocery stores and stuff like that. Or you're going to look at supply chain attack style things where somebody hoards a 0-day and they know, oh, this store we know uses this device in 25,000 locations, and here's an O-day. We got in. Yep. Yep. Yeah. So the issue um, that we run into a lot of times is we can only afford one of our test devices because we only made 3 of them. It's still early on in the process because we're lucky and we got brought in before it went to production, which is awesome. But we can only give you this one, so don't break it. And it really sucks when you're the guy that has to call the developers and say, hey, I know you only had one, but can I get a new one? Because, oops. Yeah, they weren't too happy. Yeah, right. It had nothing to do with the fact I shot voltage into the processor. What are you talking about? Who's an oops? Yeah, absolutely. Yep. Yeah, so like my home network, I have a firewall. You can ask my wife, we have 8 Wi-Fi networks at the house, right? So like, I have my own corporate one. I have my research one. She's got her own one. The PS4 and stuff is on its own one because I don't know if that TV is vulnerable, and I don't want them to use that to pivot into the rest of my stuff. So, if you hack my TV and then my PS4 and this and that, whatever, they're my smart devices, they stop working. that sucks. I don't want you to steal my credit card because you dropped ransomware on the rest of my network. Whoever. Yeah, so the question was, heard about these smart home hubs, what are they for? Well, yeah, that's great because that could also be your pivot point. So maybe your smart home hub is the thing that's publicly facing, and then all your IoT devices are behind that. So maybe, you can't directly connect to these, but you could hit that, find something there and land on that device, and then pivot onto other devices or around the network, depending on segmentation and stuff like that. So like, it's another thing of IoT devices is it's not just the IP camera, but it's when it comes with the IP camera and an additional router and a this and a that, like all those components should be tested as separate engagements as in total, because like you should really dig into each component and then see like, can you find a weaponized exploit to go all the way through the chain and end up on a company server or something like that. Yep. Question was, what got me into IoT? So I was doing threat intelligence for a company, and I was looking for a pen tester job, and I could not get a pen tester job to save my life. Everyone wanted 5 years experience in the corporate side, not playing around at home and hacking around, which is a whole nother talk. But I interviewed with this company, and I actually didn't really understand what the job title really was. I just thought it was kind of like network pen testing. So like, all right, cool. And they brought me in. They're like, what are all these protocols? Oh, I have no idea. I was like, but I can learn, and I will figure it out. And I got lucky, and they took a chance, and I had a mentor who was like, I got my bachelor's and my master's in IoT pen testing. Here's all of my knowledge. And I just drank from a fire hose for a year. Going home mentally drained because I was so tired from learning all the things. So that's how I got into it. There's some courses online. I'm going through the Adify course right now. Kind of price things like $2,500. So maybe ask your company to do it, but it's cool because they send you devices to hack as well. So they'll send you like a camera and a Bluetooth lock and things like that, so you can get into like sniffing Bluetooth, and they give you the tools to do it as well. So you'll get like Bluetooth sniffers and things like that. Yeah. Yeah, I'd like to do one of those at some point. Yeah, right. Yeah. Can you repeat the question one more time? Yeah, you could look. You like connect directly to your IoT device, and then you look at like if it's running some kind of like small Linux or something. You can look at like Etsy init files to see what it's doing when it's booting. So like if I'm the attacker, I'm not gonna exploit the IoT device and not leave myself some kind of backdoor, right? So you could go and also download the firmware for the current image and compare it against your own. Like, oh wait, there's netcat on my home, but there's not on this one, or there's this binary, but it's not here, and they're the same versions. And anytime, like, look for your IoT device to be trying to talk to other things, right? If suddenly you're on, 192.168.1.x network, and your IP address is .2, and it's trying to talk to 3 and 4 and 5 and 6 because someone's just ping sweeping your network, your IoT device should not be doing that. Yep. Yes. So the question was, any devices that I've tested, have they been using Secure Boot that I've been looking at? I haven't seen it. It's kind of uncommon, and I think it's kind of that. I think it's been around for a while, but it's kind of newer for companies to start putting that into their devices. Unfortunately, because it makes your job a lot harder, but there are still ways, you could still corrupt it as it's booting up maybe, and it falls back and gives you information or a shell or something. But it does make it a lot harder, right? You can't just U-boot, shell, and win. It makes things complicated. Any other questions? Yep. Yeah. So I did it internally for a while, so I just disclosed it to my internal teams and had meetings with them as any standard like pen test style report. Hey, we found these. And it's really helpful in your reports when you write them to have like this is the vulnerable code, right? It would be really bad to just be like, hey, you have command injection on login.html. And they're like, okay, like I understand there's only two parameters, but like, if you can pull out the decompiled code and be like, hey, it's here, it looks close enough to their actual code that it can go and help find that stuff. All right, and that's my time. I'll be around the con. I'll stand outside if you want to ask questions.